Python fundamentals, data types, operators, user input, print, packages, debugging. Introduction to Python fundamentals. Topics covered in this notebook. Data types in Python. Why data types matters. Code build in data types. Integer, int, float, string, str, boolean, bool. Typecasting in Python. What is typecasting? Why typecasting is needed? Code typecasting functions, numeric conversions, string to numeric conversions, Boolean typecasting. Operators in Python, arithmetic operator, comparison operator, logical operator, assignment operator, bitwise operator, membership operators, logical operators in NumPy and Pandas, FYI. Taking user input, the input function always returns a string, type conversion after input, system and OS operating system and OS interaction, introduction to modules, using the platform module, checking 32-bit versus 64-bit, file existence, os.path, file existence, os.path, working with directories, getting CPU count, introduction to the sys module, printing and string formatting. Basic print function uses multiple value printing, string conventions, string concatenation, not convention, string concatenation, dot format function method, f string or f dot string, you can say f string, escape characteristic, escape characters, multi-line strings, mathematical expression and operator precedence. Writing expressions in Python, operator precedence rules, solving x plus y into x plus y or x plus y the whole square, simple finance calculation, future value formula, implementing in Python, formatted output, conditional statements, if statement, if else, if else, equality, sum, difference equal to 5 program, basic geometry program. First is area of triangle formula, static implementation, user input version, package management. What is a package? PIP versus Conda, pip versus Conda, installing, upgrading, removing packages, importing packages, basic import, import specific functions using aliases, import module from a package using alias. Why import is important? Creating and importing own module, debugging and basic profiling, types of errors, reading traceback, using help function, basic timing with percentage time. Data types in Python. Why do data types matter? In Python, everything is an object. Each object has a value, a data type, associated behavior methods. The data type determines what kind of operations are allowed, how the data is stored internally, what built-in functions or methods can be applied. Understanding data types is the foundation of writing correct programs. Core built-in data types. Data type description example. In data type, integer value description, whole numbers. Or example is 10 minus 500. Float data type description is decimal number. Example is 3.14 minus 2.5. String data type description is text sequence of characters. Example in string hello, in double quotes hello. Bool data type boolean values is description true or false. Example. FYI, how these appear in NumPy and Pandas. When we move To NumPy and Pandas, data types become slightly more specific. Below is a comparison to give you an early idea. Python type, NumPy equivalent, Pandas representation. Python type is int 32, int 64. NumPy equivalent, int 64. Float, float 32 or float 64, float 64. String, object or string, then object. Bool, bool dash or bool underscore you can say. Important note, in pure Python data types are flexible and dynamic. In NumPy data types are more strict and memory optimized. In Pandas data types are built on top of NumPy types. You do not need to memorize these now. This table is just to prepare you for what you will see later. Integer, that is int. Create an integer x is equal to 10, checking its data type x, int. Integer represent whole numbers. They can be positive, negative or 0. Float. Creating a float y is equal to 3.14159265. Checking its type, that is type y. Type y is float. String data type str. Creating a string, name is equal to double quotes data science. Checking its type name, that is a string str. String represent textual data. They can be written using single quotes, double quotes, triple quotes. String concatenation, extra space is also count as a character. A is equal to single quote Harry. B is equal to inverted comma Potter. Name is equal to A plus space in single inverted comma plus B. Print name Harry Potter, Harry space Potter. Subsetting and slicing a string. Print name 0, print name 0:5, print name 6 colon, print name -1, -3, -3 colon. Output H Harry Potter RTTER. -3 represent TER. -3 represent T or -3 colon represent TER. -1 represent R. String multiplication, print double inverted comma Harry into 2, Harry. String methods practice, print inverted comma, single inverted comma, Harry dot upper, print capital Harry in uppercase in single inverted comma dot lower, print in inverted comma Harry in uppercase, Potter in capitalized manner dot title. Output in uppercase Harry, in lowercase Harry, and capitalize Harry, then Potter, Harry space Potter. Name is equal to Harry Potter star dot join name in single inverted comma star dot join in bracket name. H star, A star, R star, R star, Y star, space star, then so on for Potter. Replace sentence is equal to in single inverted comma I am a data analyst. Print sentence dot replace in inverted comma analyst comma in inverted comma scientist. I am a data analyst first output, I am a data scientist second output. Split. Name is data science engineering in double inverted comma. Name 2 is name dot split in hyphen hyphen in single inverted comma. Name is equal to, name2 is equal to data science engineering. Data in single inverted comma, science in single inverted comma, engineering in single inverted comma. Typecasting in Python. What is typecasting? Typecasting is a process of converting one data type into another. In Python, this is very common because Python is dynamically typed. User input is always taken as a string. Mathematical operations require numeric types. Why do we need typecasting? Consider this example. X is equal to 10, y is equal to 20. Print x plus y 1020. The output is 1020 because Python treats them as string and perform concatenation. If we want mathematical addition, we must convert them to integers. X is equal to int in single inverted comma in brackets 10, y is equal to int 20, print x plus y, output is 30. Now the output will be the 30. Code typecasting function in Python. Function converts to int integer, float function float, string str function string, bool function boolean. Converting between numeric types. A is equal to 10, that is int. B is equal to float A, convert to float. Print B, print type B. Output is 10.0, class float. Converting string to numeric. Num is equal to 25 in double inverted comma. Converted is equal to int num, print converted, print type converted, output 25, class int. Important, the string must represent a valid number. Example, Python int inverted comma, double inverted comma, ABC. This will raise an error. Boolean typecasting. Bool 0 false, bool 1 true, bool space false, or we can say double inverted comma false, bool double inverted comma high true. That is true. Rule: empty values is equal to false, non-empty values true, 0 is equal to false, non-zero numbers true. When is typecasting successful? A type conversion is considered successful if it does not throw an error, the value makes logical sense, the transformation can be meaningfully interpreted. Example, int 10.9 is equal to 10. Although it works, information is lost. So, not all successful casts preserve full information. Thus, the hierarchy for typecasting looks like exclamatory, image2.png, attachment colon image2.png. Operators in Python. What is an operator? An operator is a symbol that tells Python to perform an operation. Example, 5 plus 3 here. 5 and 3 operands, plus is operator. Operators allow us to perform mathematical calculations, compare values, build logical conditions, modify variables. Arithmetic operators. Operators meaning example result. Plus operator. Addition is the meaning. 5 plus 2 is equal to 7. Minus subtraction. 5 minus 2 is equal to 3. Multiplication. Star multiplication. 5 star 2 is equal to 10. Division operators, forward slash, that is backslash, 5 backslash 2, that is 2.5. Double backslash, that is floor division. 5 double backslash 2, that is 2 times divided. modulus amp modulus percentage sign modulus remainder 5 percentage 2 is equal to 1, that is remainder. Double star exponent 5 double star 2, that is 25, that is exponent or 5 to the power 2. X is equal to 5, y is equal to 2, x plus y, x minus y, x into y, x by y, x double divide by y, x modulus y, and x double star x to the power y. 7, 3, 10, 2.5, 2, 1, 25. Backslash always returns a float. Double backslash removes the decimal part. Modulus gives remainder. Double star means power. Comparison operator and meaning double equal to, that is equal to, not equal to, or exclamatory equal to, that is not equal to, greater than, less than, greater than equal to, less than or equal to. A is equal to 10, B is equal to 5, A equal to B, A not equal to B, A greater than B, B, and A is less than B. False, true, true, false. That is the output. You can see here. Comparison operators always return Boolean values, true or false. Logical operator are used to combine conditions. They are heavily used in decision making. Operators meaning AND operator, both condition must be true. OR operator, at least one condition must be true. Not operator, reverse the result. X is equal to 10, X is greater than 5, and X is less than 20. Print X is greater than 5 or X is less than 3. Not X is greater than 5. Output first is true, second is true, third is false. Logical operators in NumPy and Pandas. In pure Python, logical operators are AND or NOT. However, in the NumPy and Pandas, we use different symbols. Context, AND and, OR, NOT not. Pure Python, AND or NOT. NumPy, Pandas, ampersand, division, ampersand, what is that? Ampersand, forward slash, and curvature swing, लगभग, near about. Why this is different? In Pandas, NumPy logical filtering is performed on entire arrays or columns. The keywords AND OR do not work element wise on arrays. Instead, we use ampersand element wise AND, that is bar for element wise OR, and the last one is element wise NOT. We can see is near about. Double star, always remember that AND or single Boolean values. Ampersand for array or column wise comparison. Very important rule in Pandas: when using ampersand or bar, you must wrap each condition inside parentheses. Example, Python, data frame age greater than 18, ampersand data frame salary greater than 50,000. Assignment operators. Operator and meaning equal to assign value, plus equal to assign, add and assign, minus equal to subtract and assign, multiply equal to multiply and assign, divide equal to divide and assign. X is equal to 10, X plus is equal to 5, print X, X into equal to 2, print X, output 15 and 30. Membership operators are used to check Whether a value exists inside a sequence, they return true or false. The two membership operators, operator and meaning, in operator returns true if value exists, not in returns true if value does not exist. L is equal to 5, 22, Harry, 12.23. A is equal to 44. Print A in L, false. Print Harry in L, true. Output false and true. The operator checks whether the element exists inside the list. Example with the string. Word Harry Potter in double inverted comma like a string. Print W in word, false. Print H in Harry Potter, true in case sensitive. Print uppercase H in Harry Potter, true. Output false, false, true. For string, membership checks whether a character or substring exists inside the string. Using not in, print 5 not in L, print Z not in word. Output first is false, second is true. Note, membership operator works with string, list, tuples, sets, dictionaries or keys. This becomes extremely important when we study data structure, filtering, searching and data validation. FYI membership in pandas. In pure Python we use value in sequence. Example Harry in I, Harry in bar. Example Harry in L. In pandas when we working with the entire column series, we use dot is in function. Example preview df animal dot is in lion comma tiger. Important, in works for single value checking. Dot is in function works for checking multiple values across the entire column. We will study this properly when we learn pandas. Bitwise operator, awareness level, operator and meaning, ampersand and bar or power, XOR, near about, not, less than, left shift, greater than, right shift. Bitwise operator works at the binary level. We will not deeply explore them now, but it is important to know they exist. Bitwise operator versus panda logical operator, ampersand, bar and near about appear in both bitwise operators. Pandas logical filtering. They are the same symbols, but they are not being used the same way. What are bitwise operators really? 5 ampersand 3 1. A binary view of the above operation looks like 5 denotes 101 brackets, 3 denotes 011, that is 101 octane number, you can say octadecimal. 001 denotes to 1. This is low level binary logic. What happens in pandas? Consider Python. Data frame age greater than 18, ampersand data frame salary greater than 50,000. Here data frame age is greater than 18, produce a series of true or false. Data frame salary greater than 50,000, produce another series. Now ampersand operates element wise. True and true is equal to true, false and true, false, true and false, false, true and true, true. Resulting false and false is true. Like this I am saying. resulting in true, false, false, true. Thus, while the symbol is the same with integers operators on bits, with the Boolean arrays operators element wise on each Boolean. Why? Because NumPy and pandas overload the operator. We use and in pandas. It will fail as because Python expects a single true false, not a whole array series to be precise. Taking user input in Python, the input function. The input function allows a program to accept input from the user. Syntax Python input message to display. Example, name is equal to input, enter your name, print name. Output, enter your name, that is data science, data science. The text inside quotes is called the prompt message. It tells the user what to enter. Important, input always returns a string. Even if the user enters 25, the type will be string. Why? Because input function always reads data as text. Converting user input to numeric type. Age is equal to input, enter your age, print type age. Output, enter your age 33, class string. Notice how the data type is str. To resolve this problem, you have to pass convert the input into a int. Age is equal to int, input, enter your age, print type age, enter your age 33, class int. Now the input is converted into an integer. This is very common in programming. Take input, convert type, perform operations. Addition of two numbers. X int input, enter first number. Y int input, enter second number. Result x plus y. Print sum is result. Output, enter first number 2, enter second number 4, sum is 6. What happens if we don't convert? X input, enter first number. Y input, enter second number. Print x plus y. That is enter first number 2, enter second number 4, that is 24, not 6. Here we are not converting. Here we are not using int. Notice if user enters 24, then output will be 24 or 24 because string concatenation happens. Recommended patterns. X is equal to input, enter a number. X int x, enter a number 2, or more commonly x is equal to int input, enter a number, enter a number 2. Both are correct. The second one is shorter and widely used. System and operating system interaction in Python. Introduction to modules. So far we have used only Python's built-in features. However, Python becomes powerful because it allows us to use modules. A module is simply a file containing Python code that provides additional functionality. Instead of writing everything from scratch, we import modules and reuse their capabilities. What is a module? Think about a module as a toolbox, a collection of pre-written functions, a collection of useful utilities. Python has many built-in modules such as OS, SYS, platform, math, datetime. How to import a module? Import platform. Once imported, we can access function inside the module using Python module name dot function name. For example, Python platform dot system and brackets, that is the function. Using the platform module, the platform module allows us to retrieve information about the system on which Python is running. It helps answer questions like which operating system I am using, what version it is, and is my Python running in 32-bit or a 64-bit mode. Getting operating system name. Import platform, platform.system function, that is Windows. Getting OS release version, platform.release, that is 11. This returns the system's release version. Getting detailed platform information, platform.platform function, Windows 11 10.0 dot 2600 SPQ SP0. This provides detailed information including OS name, version, architecture. Checking 32-bit or a 64-bit Python, checking 32-bit versus 64-bit Python. Platform.architecture function, 64-bit Windows PE. Import platform, print operating system, platform.system function, print OS release, platform.release function, print architecture, platform.architecture function in array 0. Output operating system Windows, OS release 11, architecture 64-bit. Checking file existing or a checking file existence using the OS module. The OS module allows Python to interact with the operating system. It provides function to work with files and directories, access file path, check file existence, and create or remove directories. Import OS, checking if a file exists. os.path.exist file name, that is false, true. This function returns true if the file exists, false if the file doesn't exist. Example, import os file name is equal to example.txt, print os.path.exist file name, that is false. Practical version with user input. Import os file name is equal to input, enter a file name. If os.path.exist file name, print file exists, else print file doesn't exist. Output, enter file name random.txt, file doesn't exist. Working with directories in Python.